Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gil Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gil@eapen.info. My guest today is Professor Jean Camp, who is a professor at the School of Informatics and Computing at Indiana University. She is a fellow of the Institute of Electrical and Electronic Engineers and a fellow of the American Association for the Advancement of Science. Her research goal is the security that people need, the privacy they want in systems they can trust. Welcome, Jean.
Thank you for inviting me. I appreciate it.
Absolutely. I want to start with one of your papers, Reconceptualizing the Role of Security User, in which you say the internet is not only critical infrastructure that relies on the participation of unorganized and technically inexpert end users. Transportation, health, waste management, and disaster preparedness, you say, are the other areas where cooperation between unorganized citizens who lack experience with the domain has increased resiliency, reduced social costs, and helped meet shared goals. Theories of community-based production and management of the commons explain this type of cooperation, both offline and online, you say. So what is community-based production in the context of internet?
So the basic concept with community-based production is that you can have something that's perceived as a commons, and the classic example of that is a fishery. It is very hard to stop people from going out and catching fish. So in economic terms, it's not excludable. It's hard to stop people in a community from getting on their boat and going out and catching a fish. In economic terms, it's also what's called rivalrous, which means if I catch a fish, you can't catch a fish. And that combination of features is what defines a common pool good. So we're all used to the tragedy of the commons, and there's also this tragedy in common pool goods. So what I was saying in that paper is that we should look at the human component of economics of security, of security using an economics lens, because right now the focus on people is they should be more compliant. They should be better at reading phishing emails. The general idea is that there's this huge pyramid of security above us, and then the tip of that pyramid is pointing down on the user's head, and they have to do everything right, and if they screw up, the whole thing collapses, right? And each of us is kind of alone in that. You get your training, you should, learn the 12 things that help you recognize phishing emails. But if we were able to work collaboratively and share more information, then we could have a better outcome for everyone. So a lot of my work is focused on having the computer trying to
Yeah.
serve the individual. So, for example, if I go to a web page I've never gone to before, the
Hmm.
computer knows that. If I go to a web page that none of my friends have gone to before, right, in my social network, the computer also knows that. But
Right.
it doesn't tell me that. It doesn't tell me this is an unfamiliar page. That is the
Hmm.
kind of information that we could create if we shared information with each other.
Okay. So if we do that, you argue everybody's better off. You say in the paper, community-based production can drive the creation of any good that possesses the following characteristics: modularity, low capital requirements for entry into production, low marginal cost of production, and well-defined interfaces or interactions, resulting in low cost of integration. All of these properties exist for the internet, right?
Yes, they do. And I would love to say that that was my original insight, but I have to shout out to Yochai Binkler here, who
Mhm.
wrote the paper Kosa's Penguin. That
Yeah.
in this case, we could share relatively small amounts of information and know what is familiar and what is well known. And that familiarity, in fact, according to human subjects research, is part of what makes it easy to entrap people in phishing attacks.
Okay. So,
The first,
there could be a human component of sharing, but you also mentioned, with machine learning and artificial intelligence, you could have the computer making some of these decisions, right? So how do those things interact, and what might be optimum?
oh, that is really right to the heart of my some of my research questions. Thank you.
Okay, sure.
So one of my continuing struggles in working in security is how do you get the computer and the human to work so that we have an optimal partnership. So the name of my group, is HATS, Human and Technical Security. With you can tell this comes from my um, Southern upbringing, that the right hat for the right occasion. You are never going to wear that church hat to the baseball game. So
Right. Yeah.
the the idea being that if we can determine the context that the person thinks they are in and
Hmm.
share enough information about that context, then the person can make the right decision. Because you don't want to tell people, oh, you don't ever want to go to an unfamiliar website, because the fundamental experience of being on the internet is one of discovery. But you don't want people to believe that they are in a highly familiar place that is very trusted, when they are, in fact, in some odd little malicious corner.
Right. Right. And so correct me if I'm wrong, Jane. So the way that I think about this then is, we are getting autonomous vehicles now. Increasingly, we're going to have fleets of autonomous vehicles, and the idea would be that vehicle to vehicle communication would be sort of automatic as well, right? So are we heading toward sort of machine to machine conversations to be automatic and be sort of optimizing for the entire community, or or is it still people involved in this process? How do you think about this?
Human and computer judgments are very different, and we have very different strengths.
Yeah.
So when you talk about something like long haul automobile driving, I think that is a great place for computers. Going down the highway where there shouldn't be any movement perpendicular to the highway. So the computer should be able to detect a deer or a dog or, in the absolute worst imaginable case, a human, and preventing accidents between humans. I think that's great. But then when you move into an environment where a lot of the interaction is just human. So if you are driving down the street,
Yeah.
and you see two kids playing with a ball, you know to slow down, because you know that kids who are playing will focus on their toy and one right out in the street in front of you, right? You see, a kid on a bike, you're like, oh, I'm gonna make a major, give them a lot of space, or somebody who's wobbling on their bicycle. And we do a lot of human interaction when we drive. So when you are stopped at a stop sign and somebody walks up, you look at their face and their body language to decide if they're going to walk in front of you or not, right?
Right.
So there's definitely going to be a component of human judgment in that for a long time.
Yes.
Again, and that's where people are very good at context.
But from a security perspective, Gene, wouldn't you say that the human is sort of inferior? Let me make the statement, and you can you can tell me if it is right or wrong. I would argue that the human is sort of inferior to assess security issues and to intervene in the presence of a break, a security break. Whereas a computer might be faster, better, and really superior to human. I'm just talking now, totally in the context of security and internet. Is that not true?
Computers are better than humans at what? They're better at recognizing the familiar from the unfamiliar, but they are terrible at determining if it's going to be a benefit for the human to go to the familiar or not. So let's take an example where you are sitting at your computer and you maybe are in a terrible pandemic and are feeling a little
Okay.
isolated and having a miserable day. And so you decide to go to a site that is familiar. So I get no money from this site, but I will tell you that sometimes I do go to Kitten Wars, um,
Okay.
which is like, it makes me smile, and it's very short kind of commitment.
Yeah.
A computer's optimization would say, I should not go there because it's not productive. It's
Okay.
not. And when you start having automated decision making based on invisible optimization and you decrease human autonomy, yes, maybe you can get more security narrowly construed, but you are paying a critically important price on human autonomy. So, for example, we don't make cars that can't speed. We don't make cars that can't speed because sometimes the safest thing to do is to speed. Sometimes you want to swerve out of the way. Sometimes you want to pass another car that, is going 5 miles an hour. And to say, all right, well, you're just trapped behind this other car because you would have to speed to pass it. Would be to say, this is a risk that you as a human, the infrastructure has decided we cannot take. And then maybe you live in a rural area, or for another reason, you are the fastest way to get to the hospital is to put the person in the car and drive to the hospital, right? And
Right.
we allow people to take physical risk. But when you are taking these physical risks, you have been acclimated to it your entire life. People are used to cars. And there is a lot of protection for you in the worst case. So in 1970, to go with the metaphor of automobiles, in say the 70s, you could get in an accident where the people inside were literally killed, right? People would go through the windshield, and it was like, yeah, man, people just go through the windshield. Too bad about that. But then we decided that's not going to happen. And now automobiles collapse around the human. We're still allowed to take risk, but if there is a problem, it collapses around the human. And the nice thing about automobiles is they are dealing with physical force, which is absolutely deterministic, right? But all the machine learning models and AI are fundamentally about correlations and predictions. They're very stochastic. So when we don't have the certainty that you are definitely at risk, right?
Right. So again, going back to the internet context, community-based production. So what is sort of the headline here, Jean? Is it that we can, if we share some information, in this case, humans are making those decisions with a larger community, it doesn't matter how your level of expertise might be. It doesn't matter how knowledgeable you are, how internet works, and so on. It actually results in an overall benefit for the community. Is that the argument?
Yes, that we are. So there are two things that we are not doing in security. We're not treating it like the humans are partners in risk management. We're treating it like the human is at the tip of the pyramid and holding it all up. At the same time, they're not getting the support that they need. And we are creating these crash conditions where once a person makes one bad decision, the entire computer is damaged, right? So so one of the things that I'm seeing, I don't know, I admit I read this on Twitter, all right? So I know the person there is working for Google. They may just be thinking out loud. They were talking about reducing functionality of unfamiliar sites. So if I go to a brand new site and it's completely untrusted, I may have to click a few more buttons to choose to allow this software to run on my machine. Right? I will know that it's unfamiliar because I will have the experience of engaging with it as new and unfamiliar.
Right.
So that is, for me, an example about how things can be made to collapse around the user. I think the worst example of this in technology today is really the way the public key infrastructure is treated. So if you look at the baseline of the certificate authorities are the entities that sign the cryptographic attestations of trusted domain names. So in other words, a certificate authority decides whether or not you have a little lock on your browser.
Right.
When you download it right now, actually, many people only interact with a handful of these, right? And they think, oh, these are the people I trust. I trust Microsoft. I trust Google. You pretty much have to trust some of the larger certificate authorities. But if you look at some of the attacks on the subversions of these, one of them, for example, was a public transit company in a city in India that had a technical failure, and signed a certificate, signed a bunch of certificates and attestations were signed, right? And people were like, well, the human cannot be expected to know when they open a web page and it says, google.com, that it was signed by a taxi company in India. It was actually public transport, I guess. That maybe we should be making explicit decisions to trust beyond or across jurisdictional boundaries, or to trust new and different entities. That's what I mean. All the computer could do was say, hey, yeah, this was totally certificately legitimate. Whereas if the human had the information that I've never encountered this certificate authority before, then the person could have recognized the context. On the other hand, if I'm going to India, because I do believe travel is a thing that will happen again, I may want to be buying a bus ticket before I leave.
But who appoints the certificate authorities? What is the process there?
Well, in some places it's quite opaque, but when it comes to the public internet, which means signing domain names, which means that a lot of the IoT and cyber physical systems depend on this too, the governance of that entity is literally the certificate authority browser forum. We have an entire infrastructure that was built basically assuming credit cards, right? I'm going to buy a sweater and a software package, and if one of them is bad, I can return it. And it really has not evolved to the modern threat infrastructure.
Right.
Like when CAs were the browser forum was spinning up, the big hot new threat was somebody who was bored writing a malicious word macro that said, I love you, And that was irritating and a little funny. But now we have large organized crime that is protected by nation states, and individual humans can't be expected to stand up to that by themselves.
Right. So there are many ways you can get fooled. And so again, from a sort of a community-based production perspective, so what is the prescription? How do an individual counteract, or can she counteract? What is the prescription?
Well, I think about the automobile metaphor where you want the computer to collapse around the person. And is to say, when I am in a different environment, so if, travel will happen again. So I put my phone in my pocket and I'm in a room and the phone has the location of the room. the phone has the knowledge that all the devices around me are unfamiliar.
Mhm.
And as a contextually aware human, I have different behaviors in that environment than I do, and a different risk profile in terms of my phone and my wallet and my physical person and my money than I do right now, where I am, I'm sitting at home. Every device in this house is completely familiar to every other device.
So are you suggesting that intelligence built into the phone and the
Yes, we
devices?
need to have more customized intelligence in the phone. I mean, the irony is, if I wanted a pair of shoes, I could go to Converse and get this incredibly customized pair of shoes just exactly for me. But when I download a machine learning system from an AV company, or when I install a browser, I get the same trust defaults that everybody else on the internet gets. And I am going to say that my personal risk and trust, um, I preferences and profile is more different from other people's than our feet are different. I'm perfectly happy to
Mhm.
die on that hill.
Yeah, so I see that from a technology perspective, Gene. So where does the sharing come in here from user to
So in
user?
that case, if you think about sharing, maybe you are in a, to take it to, a workplace where there's, or a home where there's a set of devices, and these devices have histories and patterns of use, right? And then they start to deviate from that pattern of use. So we are sitting in in a conference room, and all our computers are, they're checking mail, or we're, and then suddenly one computer starts connecting to a site that has got an attestation from a CA we've never seen before, or everybody else's machines are behaving the same way, and this machine is suddenly uploading massive amounts of data. The other machines in the room see it. So if
Okay.
say there's 4 of you in the room, and the person who's chairing the meeting, their machine is suddenly broadcasting huge amounts of data, you might ask the adjacent machines, this machine is massively broadcasting. You might want to notify that person. Because,
Okay.
oh, sorry.
No. So sort of an environment security score, so
Yes.
to speak, right? So it's not just a device; it's really all the devices in an environment. And just like the autonomous vehicles will communicate with each other, they would be in a position to communicate with each other, and that allows you say sort of a better protection for all involved, for the entire
Yes.
community.
And right now, we don't have enough information to protect ourselves or each other. And so one of the
Right.
things that I think we are going to see in the coming years, as we all have become much more aware of things like ransomware and the risk that we're all exposed to, is you may see the emergence of social norms that,
Right.
um, having a computer that is running malware becomes socially unacceptable. But to
Right. Okay.
use
Okay.
social norms means having some kind of transparency about, if not, what website you went to, how much risk you're taking as a whole.
Right. And if one unit in a network is infected, really the network is at risk as well, right? So it is a common pool of risk that you want to manage, equipment by
Yes,
equipment.
exactly. So if you have, so we think about access control. If I'm at work, I want access to everything because I don't want anything to get in the way of me doing my job. And everybody else has the same goal, right? But if we had, for example, if you have a department of 6 people and you have a risk budget, right? Just like you have how much, there's assumed you use this much paper, you have this salary pool, and other levels of cumulative exposure to risk, not just families, but work groups can take a certain amount of risk, right? They can use a certain amount of resource. And if we start to treat
Right.
risk as a commonly managed resource, we can also get information that allows people to self-manage more effectively. So if you have a group of
Right.
people and one of them is, downloading every single possible video from TikTok that has a cat in it, which might be, humanly impossible, regardless of where it comes from. And then you have other users which are not taking that risk, but want to access another device. Having that kind of community management is a better way than just saying, oh, and you can never download a cat video ever. Because if you're too constraining, people will work around you. If you don't allow people to be human and to be a little variable, they are just going to, subvert your constraints.
Right. Yeah. If you put too many prescriptive constraints, it becomes a game get around it, and that wouldn't help anybody. So, Jean, we need to take a quick break. When we come back, I want to talk about your macroeconomic analysis of the routing
Great.
anomalies
Thank you.
paper. This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com. So we are back. Jane, I want to go into another paper entitled Macroeconomic Analysis of Routing Anomalies, in which you say routing anomalies beyond simple leaks are occurring on the order of tens of thousands a year. These may be accidents, but there is anecdotal evidence that indicates criminal intent. So any given anomaly could be an accident, a crime, or an attack, although it's impossible to directly observe the motivation of those who generate these anomalies. Aggregate data about the sources of those anomalies is available. Now, a routing anomaly, Jane, just for my own understanding, you go from node to node on the internet. I don't quite know how how a packet is routed. And so is there an expectation that a packet will be routed in a certain way, and an anomaly is something that shows up when the packet is not routed the way that was intended?
Yes, there is a tremendous amount of resilience in the internet because of the way the autonomous systems, the networks connect to each other. And the way they connect is when you want to go from one point to another point on the internet, you don't establish a connection and reserve resources. You say, here's my data, ideally encrypted, right? And please deliver it the best way possible.
Right.
Now, one way to get data is to send out misinformation about where you are located. So we've had some very interesting routing that has occurred. So, for example, for quite some time, packets that went from Denver to Denver went via an ISP in Iceland that appears to have been subverted by Russia. And so you might be thinking, well, rural Colorado outside of Denver, that is so boring. Why would they want that? But in fact, it's very interesting. It's where NORAD is and Cheyenne Mountain. And, there's quite the Air Force Academy. There's quite a lot of assets there. And so...
But how is the route determined? What is the mechanics?
So so there a lot goes into how routing is determined. But there are 2 or 3 basics. One is the distance. So if you are the closest person to where I want to go, I will give my packet to you.
Okay.
The other is customer relationships. So if you are already my customer and I'm certain that I won't have to pay extra for you to route this, you may be a little further away than other people, than the strictly closest person, but I'll still give you my packet. And if you think about closeness, there's also a congestion, right? So perhaps you are the closest person and you're my customer, but you're already overwhelmed. So anything I would give you would go into a queue that you would handle later. I don't want to do that. I'll go to the second best route.
Okay, there's some sort of optimization. So distance, congestion, the customer relationship. So when a packet is routed from X to Y, is that a transaction that is monetized by some way?
Are there per packet charges? There is certainly traffic and bandwidth charges. And if you are doing that on the old-fashioned, telecommunication services, there are publicly regulated agreements about how much can be charged. But if you're doing it on the internet in a packet service, those agreements are called peering agreements, and there is not transparency there. So you are going to have to get somebody way above my pay grade to tell you about how those are negotiated.
Okay. And so very simplistically, distance and congestion are the sort of the driving factors. It will look sort of odd going from a place in Denver to another place in Denver through Iceland. And so that is what you mean by an anomaly, right?
Yes. Now that was actually a hijack. There was another kind of that is reasonable to assert that, when we kind of jokingly made our paper Incompetence, Criminals, and Spies, that would be the spy category. There are also people that do routing hijacks for money. So really easy to understand one is that there was a bunch of people who came together to form a mining pool, which is really common. and they all invested all of their shared resources into mining Bitcoin, which is really just making a calculation over and over and over and trying to get an output of a certain type. And so the likelihood that any one person will get this output is low and also unpredictable. And so people form groups and they say, oh, well, the X, all of us will get together and we'll just split the rewards.
Okay.
So they were doing that. And then every time they got a hit, every time they got an actual, coin, they were depositing it in an unauthenticated Amazon cloud. They didn't even have a password. And so somebody noticed this, and then they just sent out an announcement that was like, oh yeah, this one IP range that you're using on Amazon cloud, you should definitely travel past me to get there. And then they just watched the traffic go through and pulled off the Bitcoins.
So in this paper, you say we examine anomalies as likely due to incompetence. It could be incompetence or accidents, potential crime or intelligence operations or an attack, using macroeconomics by leveraging three theories from criminology and global measures of technology adoption. So what are the three theories you talk about here?
Oh, that is super fun, because the thing about using macroeconomics for e-crime is that we actually don't really know what causes e-crime. I mean, what causes crime. So if you think about the offline theories of crime, there is the kind of, I'm sure you've heard the idea of just criminals rob banks because that's where the money is, right? So then in that way, what we would be looking for is kind of an expected rate of return. So that is a situation where it's strictly rational and people are self-optimizing. Right? So that was the original kind of theory of crime. People do it because it makes them money, and if you want deterrence, you make them less money. But there are other theories of crime, like the routine activity of crime is a model where the probability of crime is really a function of available targets, right? Motivated offenders for whatever their reason, and lack of, guardianship. Like it's a community that's not working anymore. So in one, if people are just trying to get money, well, then you're looking at what if they can invest and what they can return, and can we give them other opportunities. But if you look at something called, if you look at something like routine activity, that's where you get also the idea of broken windows. Like the community is broken down, nobody's following the rules. We really need to stop this, kind of constant maliciousness. Like everybody does it. So we looked at basically governance, with a structural theory of crime. We looked at economic opportunities, and we looked at guardianship, which is like private investment in security. Is it the case that everybody in your company has a password that is password 1, password 2? That is something where you think about market penetration of security software. And for that, we looked at, for example, number of secure internet servers. But then if you want to look at governance, which is everybody does it, everybody's corrupt. We looked at transparency measures from Moral Governance International.
And so the idea here is, so you could possibly use some sort of expected return measure to identify if an anomaly is just accident or something by design. Or you could use, some sort of opportunities, availability of opportunities for crime, and you say guardianship or governance that might be in place. So these things could be put together to assign a probability that an anomaly is by design or by accident?
Well, yeah. So what we were looking was, let's take some popular indicators of crime, governance, availability of targets, guardianship, relative deprivation, and see if these actually predict the sources of these, these anomalies. And we've done that with other things that we know are definitely crime. So we did that with malware and sources of spam bots. And we did it at a local state level, looking at Craigslist scams and all of those. And we looked at a Mechanical Turk versus Freelancer. So by the time we had gotten to the question of routing, we had a body of empirical and theoretical work, so that supported this kind of approach with things that we definitely know are crime. Like, we know malware is crime. So we wanted to build on that and see if these things really are crime, what percentage of them are crime? Can we find evidence that this is in fact a criminal activity versus a state activity? And then what we did when we found the results and the correlations between transparency particularly, and the data came out in two very clear clusters. When you look at the, I don't think we even drew circles around them. Sometimes when you're doing, like minimum distance cluster calculations and you're trying to show the visualization, so you put a circle around it. I don't think we even did that. We were like, look, here's clusters. And so we did this work, we did the correlations, and then we did the cluster analysis, and some of the correlations seem to predict is way too strong a word, seem to indicate that we could not reject the hypothesis that this is for-profit activity driven by a routine activity theory, that is, e-crime is kind of socially acceptable and available and a way to make money. And then the second smaller cluster, when we looked at the nodes in that cluster, they were all places that had active civil conflict. So I feel that it's very hard to figure out what is driving everything on the network and how we can use very traditional tools like anti-smuggling efforts, interventions into communities, economic controls, because to fight global organized e-crime, we need to use all the possible tools we have.
And this goes back to, so if it is possible to assign a probability that a routing anomaly is related to crime rather than just by happenstance, then going back to what we were discussing before, the devices becoming more aware and intelligent, those types of attributes could be used to at least alert the user.
Yes,
right?
exactly. Absolutely. And then if you have a situation where what is driving e-crime is relative deprivation. So then you might say, all right, we're going to try to create opportunities for the people who live here. But if you have a situation where what is driving e-crime is, hostile intelligence, you absolutely do not want to have a policy of going in there and trying to train everybody to be better at computing. So it can also drive higher level insights on how to deal with hotspots.
That's very interesting. I want to touch on another paper, Jane, preventing data exfiltration via political and geographic routing policies. So what exactly is exfiltration?
Oh, that is what happens when there's a malicious hijack. So we talked about, the attack to steal unencrypted bitcoins, and we talked about the traffic that went through Iceland. So those are cases of information exfiltration, where people should not be able to access the information as it goes across the network, but they are able to pull it off the network using an attack. And that's one of those things where we used very basic human observation. That is, if you're worried about crime and malicious intelligence agencies, then you're worried about jurisdiction. So we asked the question, in that case, in that paper, what if we just refuse to route through certain jurisdictions? What if we exchanged availability for confidentiality? Just like it is part of that having the computer collapse around the person. And maybe you're going to have to wait. You can choose between waiting a little bit and sending this, or you can choose this risk of exposure. So one of the questions we ask, either in that paper or so there were two papers on that topic. One was at a policy conference and one was at an internet measurement conference. And the policy conference said, this is a policy issue and an innovative approach that is worth discussing because it treats jurisdiction and policy and routing as an integrated problem with socio-technical dimensions. And then the paper at the Internet Measurement Conference said, all right, so we know that autonomous systems and routers have a physical place in the world. What if we took the top 50 financial institutions and looked at how they were routed and said, we are not going to connect to any of these systems that are routing through anything other than their usual jurisdictions? How disruptive would that be? And so we found that it would be quite minimally disruptive. There were only 4 banks that would have been affected, and it turned out the only bank that would have dropped off of network availability with strict jurisdictional routing policies in that month that we looked at the data would be the Bank of Tehran, because its routing varied quite a bit. Like it would sometimes go through Europe, and it would sometimes go through Russia, and it would sometimes go through China. But the other major financial institutions had not I'm sorry, not consistent
Sure.
routing in terms of their paths or their path length. That would oscillate a bit, and the route would kind of flap back and forth. But in terms of the jurisdiction through which it passed, did not change. So that's a situation where we looked at the risk of e-crime in a very different way, in a very interdisciplinary way, and then we're able to pull up data to say this is a feasible way of looking at this.
At the very highest level, though, Jane, it seems to sort of reduce the elegance of internet because it's sort of putting some constraints on it, right? But as you say, it's looking at, can the user change the objective function? Convenience versus confidentiality, or speed versus confidentiality, or something like that. Then does such a technology exist? For example, can I actually put in an objective function, which has these characteristics, and then the algorithm takes that and operates on it? Does that exist today?
Well, we wrote code to do it, and you could download it and say, I don't trust these jurisdictions. If you had a router on site, and it's open source code, and if you have information that you do that has, for example, intellectual property or national security issues, yes, you can pull that down, and you have to be a quite competent programmer, and let me recommend you some students to hire. But the other things are happening in this, right? So there's a thing that is graciously called manners that has come out in the last year, called mutually agreed norms for routing security. So that's a global initiative that the Internet Society has been advocating for. And I think, IETF and Usenet, which is very much like that first paper we talked about, where it's not simply a technical approach. It is a definition of concrete actions that specific networks should take, right? And it's about route hijacking, route leaks, all the things that we talked about, but it's about implementing norms of behavior that are not just cryptographic attestations, but specific network policies. So you could download this code that says, no, don't go to this jurisdiction, or you could demand that your ISP adopt manners, which will effectively say, don't go to that jurisdiction, because they are not behaving in the way that we need our partners in routing to behave.
Right. Yeah. So if a sufficient number of organizations adopt manners, then then anomalies are going to sort of stick up like a sore thumb, right? So it'll be easier to identify, I would imagine, both anomalies and bad
Yes,
anomalies.
both operational issues where people will come together to fix them, but also malicious behavior. So one can but hope. So I was very happy. I'm very excited about Manners. I did not contribute to it, but sometimes it's wonderful to say, I think that the world would be better if things worked this way, and here is all the data and the theory and the references that I have that argues for this, and then to see the world getting better and working in that way. On the other hand,
Right.
sometimes it's really
So,
terrible
yeah,
to be right. So we have this paper about the smuggling theory approach to organized digital crime from like 8 years ago, and we said, hey, it looks like there are some real emerging regions of e-crime, and we should be cognizant of this. And yeah, so that sometimes it's not fun to be right.
So Jane, in conclusion, where are we heading in the area of security? Are we better now than we used to be, say, 5 years ago? And looking forward in 5 years, where do you think we will be? Also related to that, do you see any specific issues related to the pandemic affecting the security?
Well, if you look at the reports of the kind of scams that we've been seeing, I want to do a shout out to the anti-phishing working group here, who've been very good at putting together data for a long time and making it freely available and building community to fight e-crime, and also the messaging, mail, and mobile anti-abuse working group. If you look at the data that's coming from industry, attackers are trying to leverage COVID. These ransomware attacks on hospitals, if a company is already under a tremendous amount of strain, for example, being a healthcare organization in a pandemic, they are much more likely to just turn around and pay the ransom. So attackers are certainly leveraging COVID. And as the pandemic continues and people become more stressed and increasingly comfortable taking sensitive information that, that in March, people, we were working at home, but it was kind of temporary. So maybe you could not touch that system for a few weeks or just go in. I think increased opportunities are opening up, but the big shift has been in the past few years from independent operators, especially you can see that we're now facing a world where organized crime is digital, and spam doesn't come from the guy down the street who's trying to drum up business anymore.
Yeah, I mean, I can see it in my own emails. It's getting more and more sophisticated, and it's almost like a constant war, right? The perpetrators get more sophisticated. We try to counteract that, and it goes on and on. So, so hopefully things will
we need to support end users by design. We need to provide better support and not just yell at people for doing something that's quite cognitively difficult.
Excellent. This has been great, Jean. Thanks so much.
And thank you so much for asking me. I really enjoyed it.
Absolutely. Thanks so much. Stay safe.
Take care. Bye.
Thank you.
This is a Scientific Sense podcast providing unscripted conversations with leading academics and researchers on a variety of topics. If you'd like to sponsor this podcast, please reach out to info@scientificsense.com.